Over a period of several days in middle March 2020, there was a meme floating around about the old medicine hydroxychloroquine. This had been brewing for some time, and by late March of 2020 in America, the meme had brought out the worst in people. They were stealing it, they were hoarding it, inappropriately using their medical license to prescribe or dispense it for everyone in their families, forcing nationwide shortages. The idea of hydroxychloroquine curing COVID-19 actually ended up killing someone quicker than COVID-19 disease itself. The word cure has to be in quotation marks because no honest doctor uses that word confidently. Hydroxychloroquine showed up on primetime TV March 18th and was touted as a miracle drug cure for COVID-19. On Monday, March 23rd, 5 days later, a couple in Arizona drank aquarium cleaner, which has chloroquine phosphate, the same salt used in the medicinal formulation, because they heard about it on TV. The husband died from it, while the wife became critically ill. It took 41 days from the first COVID-19 case to the first COVID-19 death in America, January 19th to February 29th. It took 5 days for someone to die because they inappropriately bought into the hype. This didn't have to happen. Unproven doesn't mean that it doesn't work. It just means that it hasn't been shown appropriately to work. Now, I'm not exactly sure why these associations between the people and forces who are pushing hydroxychloroquine for coronavirus are so shady, but I can tell you about how and why we got to this point and what I hope will be done going forward. If you can remember that far back, March 11th, 2020 was like any other day in March of any other year. It was a Wednesday, but it was also the week of daylight saving time here in the US. This is a time when the law requires that we set our clocks forward 1 hour. The policy supposedly helps save energy and boost consumer spending by forcing everyone to operate an hour ahead so that nighttime appears to fall just a little later. Back in early March 2020, we had warning signs that terrible things could be on the way. I think most of us in America thought that it couldn't come here, thought that it wouldn't come here, that it was just contained to China, and that we're all going to be fine. Some days later, okay, fine, it's just in Italy now, no problem, and Iran, but hey, we don't talk to Iran. America is on its own continent. It can't come over here. In case you're listening at any other time in the far future, well after March 2020, by it, I'm referring to the SARS coronavirus 2 and the resulting COVID-19 disease that it causes. At this point, I'm speaking on March 27th, 2020, the virus has likely permanently warped the psyche of every human living in a society. I clearly remember March 9th, 2020. It was the Monday after daylight saving time. I always take that day off work, whether it's from the hospital or from the office or whatever setting I'm working at that time. That morning, just minutes after the stock market opened for trading, a trigger was hit. Stocks dropped more than 7%, so trading was halted for 15 minutes. People were selling off in fear of the coronavirus, but nothing had been locked down just yet. So much for boosting the economy with daylight saving time. 2 days later, on March 11th, the World Health Organization declared global pandemic. Pan from Greek meaning all, and demic from demos, also from Greek meaning people, an incident affecting all people. Declaring this would allow more resources to flow into areas that are heavily hit. It would give governments a way to implement measures to help those affected and to limit the spread, but it didn't seem like things were getting limited. In Washington state, coronavirus was found to have been spreading cryptically in Snohomish County. We knew about this as far back as January 2020. American patient 0 was a 35-year-old man who had just visited Wuhan, China, and when he came back, he felt fever, chills, and aches. He was reported in the New England Journal of Medicine on January 31st. The problem is that patient 0 over here felt his fever for days before going to urgent care. We also know that SARS-2 virus has an incubation period of 3 to 7 days on average, with a maximum going up to 24 days or more, meaning that he had the virus at least a week before he went to urgent care, and that the virus had been spreading all throughout those days in January, continuing into February. America made the same mistake as China did back when this coronavirus was starting to go around. What do I mean by that? Well, America would not allow a coronavirus test unless someone had prior travel to China. They could have had the highest fever, the worst cough, and confirmed pneumonia on X-ray or CT scan even, and they wouldn't have had the opportunity to be tested unless they had a travel history to China. The Chinese did the same thing, except instead of travel to China, they included prior involvement with the seafood market in Wuhan City. We can look back and say this was absolutely not the right thing to do. How many people in Washington state regularly go to China? Patient zero was probably spreading it around for days, unknowingly. Those people spread it to others, and so on. But at their respective times, both countries were not really sure that this was really even a thing. You can't really say that America knowingly made the same mistake that China did, because the first case happened here January 19th before Wuhan City was locked down on January 23rd. And China took the brunt of it when their cases started exploding, but now America is taking the brunt of it in March 2022. February 29th, 2020, Washington state declared a state of emergency because of the first death from COVID-19 disease. California on March 4th, after their first death from the disease. Then Maryland, Arizona, Michigan, New York, Kentucky, Utah, Illinois, it all started to fall. On March 13th, the same day that the WHO declared global pandemic, the president declared a national emergency in the United States. By the weekend of March 14th, it became clear that life wasn't going to be the same. St. Patrick's Day parades were closed. You weren't allowed to sit at restaurants to eat. Gyms were not allowed to be open. Grocery stores were basically emptied out by panic buyers. Hospitals in big coastal cities were starting to fill up. Okay, so why is any of this a big deal? Well, the virus takes days to grow in the human body. Not everyone gets really sick from it, but those who do get sick can get really sick. The virus infects the lower parts of the lungs. Virus infecting cells kills them. The immune system detects something's wrong, so it inflames the lungs. This dilates the blood vessels, allowing more fluid to flow in so more immune cells can come in. Fluid prevents gas exchange in the lungs. You can't let out carbon dioxide, and you can't let in oxygen. Your lips start to turn blue. You start gasping for air. Every second you feel like you're gonna collapse because you're using every respiratory muscle to breathe as hard as you can. Your vision starts to black out. In the hospital, they have to stick a tube down your throat so that a machine can breathe for you. So that you don't breathe against the machine, they paralyze you with medicines. They sedate you and knock you out so that you can't feel that happening. As the days go by, your body's immune system spends its resources trying to fight the virus. But then bacteria starts to show up in the lungs. The bacteria spills into your blood, forcing the immune system to act again. It dilates all of the blood vessels in the body. Your heart can't pump blood to this because all the vessels are relaxed. It tries to beat faster and faster and harder, but the organs aren't getting that blood. They don't get oxygen, so they start to shut down. While this is happening, some of the blood starts forming tiny little clots. These lodge into small blood vessels of the organs. But this also expends those clotting factors, meaning that other parts of the blood become thin. Massive bleeding starts to happen as the organs shut down. The heart can't beat anymore, and the bacteria is floating around everywhere. And while the heart is having trouble beating, the virus enters the heart muscle and appears to slough off parts of it. If the virus gets into the kidneys, it starts killing cells there too. The heart can't pump blood to the kidneys can't filter any wastes, the lungs can't remove carbon dioxide, all while the bacteria and virus are swimming around in the blood looking for more targets. This is not the flu. And this is only one of the ways that COVID-19 disease progresses. So what can we do about this? And what does this have to do with chloroquine? Well, let's go to the fever. Chloroquine is a derivative of something called quinine. Quinine is something that we call an alkaloid, which is an organic compound that's found in nature. Organic means carbon containing. I'm not talking about food here. Alkaloid means that it has nitrogen bases. I'm going to use chloroquine and hydroxychloroquine interchangeably here because for all intents and purposes, they're medicines with the same mechanism of action. The hydroxy part of hydroxychloroquine was added in an attempt to lessen the side effects and reduce malaria parasite resistance. The active moiety of chloroquine, hydroxychloroquine, and quinine are all the same, known as a 4-amino quinoline. In Peru, the Native Americans had a legend that someone got lost in the jungle and they contracted a fever. This person became thirsty and he drank water from a pool that he found was bitter. After looking around, he realized that the water had been contaminated by the surrounding quina trees, and he thought that he had been poisoned. He thought he was going to die. But after some time, his fever disappeared and he felt great. He shared this with his tribe, who then used the tree bark to treat fever. Then the Spanish showed up in the 1600s, and they brought it back to Spain after finding out that it does affect fever. There's a point to all of this. Europe is actually pretty far north in latitude. Rome is actually on the same latitude as Chicago, and that's considered the southern half of Europe, meaning that London is further north than anything in continental United States. London doesn't have mosquitoes like India would, closer to the equator. Mosquitoes carry malaria, which is a disease caused by a parasite that kills red blood cells. While it does that killing, the parasite causes fever, meaning that while Europeans were doing what they were doing in the 1800s, they had an interest in consuming the quinine tree bark to treat the malaria that they would get from mosquitoes in the places that they were going. In the 1800s, the compound in the tree bark that killed the parasite quinine was isolated and described. Chemists also found that there was a mirror image of that same molecule present that acted slightly different in humans because it treated abnormal heart rhythms. They called this one quinidine. Okay, so we have a natural compound from tree bark that has an effect on fever. COVID-19 is known to cause fever. If chloroquine is derived from quinine, which reduces fever, then would chloroquine be able to treat COVID-19? Well, maybe. This brings us back to the idea of an alkaloid. Being a base means that it cancels out acids. Cells need acid to break down waste. Quinoline alkaloids prevent cells from breaking down waste. Inside the cell are organelles called lysosomes. These are like garbage disposal centers of the cell. These process waste created by things like the mitochondria, powerhouse of the cell. Lysosomes need to be acidic to function because they break down wastes. If basic quinine is present, then lysosome cannot be acidic. The cell cannot break down its waste. It cannot recycle any of its compounds. An analogy to this is like if you couldn't take a dump for 60 days. You wouldn't function normally if that were to happen, so this could be the way that chloroquine mediates the fever by interfering with the immune cells this way. This could be the way that it's anti-inflammatory and can be used for things like rheumatoid arthritis, where the immune system is overactive and starts attacking the body. But that's not the only way that chloroquine could work. There's studies out there saying that in cell cultures, it can add sugars to the coronavirus spikes. These spikes are how the virus enters cells to infect them, so messing with the spikes could mess with how the virus infects cells. Good. Chloroquine could also be an ionophore, which means that it shuttles in metal ions into cells, because charged molecules can't easily cross the cell membrane without a transporter. An example of an ionophore is the student who ate 5-day-old pasta. The protein made by the bacteria that grew on the rotten pasta is called cereulide, which allows potassium to flow into the mitochondria, and it stops them from being the powerhouse of the cell. Chloroquine looks like it ionophores for zinc, which in a eukaryotic cell would disrupt DNA replication. Zinc-binding compounds also appear to induce lysosome-mediated apoptosis of cells by forcing the release of cathepsins into the cytosol, which are enzymes that break down proteins, meaning that it pops open waste disposal centers, which has enzymes that can just basically dissolve everything inside of the cell. But it's likely the disruption of DNA and RNA replication of zinc that's the more likely mechanism between these. Whatever the case is, all of these experiments and proposed mechanisms are in fact just that, proposed mechanisms. We're talking about in vitro experiments in cell cultures, not actual experiments inside people. The reality is, we still don't really know all the different things that chloroquine is doing in the body, despite the fact that its derivatives have been used probably for thousands of years now by Native Americans. But based on the science and the experience that we've had over the last almost 100 years of using chloroquine for malaria, we can take a guess as to whether or not it could work for COVID-19 disease. The rationale is that it could work by preventing SARS-2 virus from replicating in the cell by allowing zinc into the cells and preventing the RNA replication, which would prevent the virus from hijacking cellular machinery. Or it could have an impact on inflammation by disrupting cellular metabolism by raising the pH of acidic organelles, making it difficult to recycle waste. Great. So that's the hypothesis of how this medicine could work in humans. So let's try it in COVID-19 patients. The scientific rationale is there. The experience of using it since the 40s is there. We know the safety profile and the side effects. So all good, right? It should be. But how would we design a trial for this kind of drug that would give us evidence that it does in fact actually work? does chloroquine treat someone who has tested positive for SARS-2 virus? The way that we would answer this is we would create two groups. On one hand, we'll have a group of patients who have COVID-19 and they'll receive hydroxychloroquine. On the other hand, we'll have a group of patients who also have COVID-19 who receive the current standard of care, which is watch and wait, provided that they're not actually critically ill requiring ICU admission. But which patients are you going to accept in this trial? Before the trial's even run, you need to decide this. If all you're going to take are patients who are young and healthy, and we know that COVID-19 probably has a good prognosis for these patients, you're not going to get good data out of this study. If all you take are critically ill patients, then you better have a good reason for why this intervention could work in a group like that. But what would the side effects of this be? We've been using this for a while, so we should know this, right? And we do. We know that 4-aminoquinolines are usually lipophilic, so they distribute widely into tissues. Because they're fatty, they can cross into cell membranes and thus have a wide volume of distribution. They can also stay in the tissue for some time. The hydroxy part of hydroxychloroquine helps mediate some of those side effects. Over a long period of time, and I'm talking years, it can accumulate and cause retinopathy, which is problems with your eye and vision. Do you remember the mirror image of quinine that's used to treat abnormal heart rhythms called quinidine? Well, the 4-aminoquinoline ring does something to the heart called QT prolongation, meaning it increases the time it takes for electrical activity to pass through the heart. If the mirror image of the drug that hydroxychloroquine is based off of is used to treat heart problems, but can also cause heart problems if there's an issue with the dose, then by nature of its functional group, hydroxychloroquine can do it too. QT prolongation leads to torsade de pointes, which is a heart rhythm that can kill you immediately, so keep that in mind. So say you have a bunch of patients coming in and they qualify for this trial. Who gets hydroxychloroquine and who gets placebo? Are you going to put your friends on the trial and everyone else on placebo? What happens if hydroxychloroquine doesn't actually work? At best, it would be as effective as placebo. At worst, it would cause someone to go blind, or even worse, cause them to die when they didn't need to die. Because before you run this trial, you don't actually know if the medicine is actually going to work compared to what we've already been doing. But because you're trying this, you hope it's going to work better than the placebo. So to solve the problem of preferentially putting your friends on one treatment group or putting people that you think are going to end up doing better just to squeeze your data a little bit, the groups are randomized. A crude way of doing this is one patient comes in, you flip a coin. Heads, they get hydroxychloroquine. Tails, they're going to get placebo. And do this for every patient. As more patients fill in, the demographics will start to equal out and look like the characteristic population of who should be affected by the disease. We use the placebo that looks like hydroxychloroquine as a tablet, as a pill, so no one can tell the difference. The only person who knows the difference is a third party keeping track who's neutral on the results. This party doesn't have anything vested in the trial. They don't care at all if it works. The people giving patients these medicines can't tell if those patients are getting hydroxychloroquine or if they're getting an empty pill. This way, the people treating the patients won't want to give better treatment to patients knowing that they're receiving medicine because they're blinded to that. And patients may want to convince themselves that they're actually receiving medicine, but they won't know for sure. Then the trial is run. Depending on the disease, it could be a couple weeks up to several years. For COVID-19, we could probably set a day that's maybe around 4 times the higher end of the average incubation period. So 4 times 7 days would be 28 days. What should we measure at 28 days? Well, since these patients may not be critically ill, we can compare how many hydroxychloroquine patients ended up critically ill at 28 days versus placebo. We could measure how many hydroxychloroquine patients were dead at 28 days versus placebo. Both of those would be good things to measure in hundreds of patients because it can tell us if hydroxychloroquine actually reduces the chance of critical illness, which is the original question. If no one gets admitted to the ICU after 28 days of taking the medicine, but half of the people who took placebo did get admitted, then we could say there's very likely a difference between both groups of patients because of the hydroxychloroquine. Because all other things equal, that was the only difference between the two. Because both groups were randomized, the characteristics of the patients were relatively equal in both groups, meaning that there were no baseline differences between the two that could confound the study results. Because the patients and the people treating them didn't know who was getting medicine and who was getting placebo, we've minimized the bias of people getting better treatment on medicine. If a study like that happened, we could reasonably say that hydroxychloroquine did in fact prevent ICU admission in patients who did test positive for SARS-2 virus. Then it would get a spot as standard of care for the disease in patients who had the characteristics that were included in the trial. This is how we get evidence to change medical practice. But the problem is that trial wasn't done by March 23, 2020. And there were people on TV, primetime TV, touting that hydroxychloroquine is absolutely a cure for COVID-19 disease. Well, hey, if they say that the medicine works on the virus, then they must have done a trial, right? Well, they did a study in France. I think calling it a trial is not right. But let's see what they did. Now, let's be clear. I want hydroxychloroquine to work. There really isn't a clear reason as to why we couldn't have done the simple trial that I outlined above. I mean, there's a lot of patients right now that you could have put on this trial. I have no idea why the French didn't do a more robust trial compared to the one that they did. If they did, we'd be further along to having better evidence for the medicine to work, because a proper trial should account for something like a 28-day endpoint. This is a critical time, and the trial as is doesn't feel like a good use of time at this particular moment. So, from Marseille, France, published as a preprint in the International Journal of Antimicrobial Agents. Okay, not a super impactful journal, that's fine, although for all the hype that it's been getting in the media, it could be something to think about. Now, this is still marked as a preprint as I'm recording this on March 27th, 2020. On Science Direct, the version that's shown on this particular day is the same as the one that was circulating around as a Google Doc, meaning that there hasn't been peer reviews since the time between that Google Doc was put out and now. I just want to point that out, and I'm not trying to be mean here, but the exact same typos and English grammatical errors are still present in the Science Direct preprint. Which means who knows how much it was really peer-reviewed since. I've archived both of them, and they're in the show notes if you want to see them. Again, I don't want to be somebody who rags on someone's English, especially since these are French authors here who probably never had English as a first language. But not even fixing your Google Doc before submitting it as a preprint, and then claiming that it's been peer-reviewed since. There's some early red flags there. So this is a trial that's looking at if hydroxychloroquine has an effect on COVID-19 disease. It's an open-label, non-randomized study. Remember what we said about randomizing patients before and not wanting to do things like putting your friends on the treatment group or deliberately putting patients who you think are likely going to meet the endpoint on one treatment over the other. Those are all the very definition of bias. It's also open-label, so everyone knows whether they're getting treatment or not, so there's no blinding here. Again, opens it up to potential bias. If the doctor and nurse knows that a patient is getting drug and they have a stake in the trial, they may be more receptive to giving more detailed care to that patient rather than someone who gets placebo. They may get worse care. Or the opposite might happen. Then the study would be confounded or influenced by a difference of care in patients because they know who is getting which treatment. Without blinding and randomization, this study is already subject to heavy bias, therefore limiting its ability to give us evidence of the study endpoint. So what's the study endpoint? It states the primary endpoint was virologic clearance at day 6 post-inclusion. The endpoint tells us the answer to what the study's asking. So rephrasing the endpoint, the question that the study is asking is how does hydroxychloroquine impact virologic clearance at day 6? What do they mean by virologic clearance? Well, let's take a look at the kind of patients that they're including. They say anyone over the age of 12 and who has PCR documented SARS coronavirus 2 carriage in nasopharyngeal sample at admission, whatever their clinical status, meaning that they tested for virus in someone's nose, like how the tests are normally done, and as long as they were positive, they were eligible. Didn't matter if they had symptoms or not, critical illness or not. They went on to say patients who were pregnant or breastfeeding or had a known allergy to hydroxychloroquine or chloroquine or had any other known contraindications with those drugs, including retinopathy, glucose 6-phosphate dehydrogenase deficiency, and QT prolongation. So the number of patients who are eligible for this study right now is actually really large. Anyone who tests positive and is older than 12. When the study authors say virologic clearance, they mean that they're looking to see if patients tested positive again after 6 days. To put it another way, they're looking to see if the virus is still in the patient's nose after 6 days of treatment. What if the patient doesn't have virus in their nose anymore because the virus is all in their lungs? What if the patient gets critically ill in 6 days? What if they're dead by 6 days? What if the virus is detected in their nose on day 5 but tested negative on day 6, only to have them come back to the hospital on day 10 positive again and critically ill. 6 days is barely the incubation period of the virus, which we know to be around 3 to 7 days with a maximum of 24. Why 6? There's no clear guidance to say 6 is a good endpoint, and there's nothing to say that just trying to see if virus is left in the nose at day 6 is a good measure of whether or not the hydroxychloroquine intervention is actually working. This is all very basic stuff. The one thing that I found kind of subject is under the conformed consent part of the paper. If you're going to be included as a data point in the study, you should know about it. You or someone who could speak for you in the case that you can't speak for yourself should be in a position to agree to be in a study and say, okay, you can collect my data and then report it. This study kind of did that, but it also didn't, because under informed consent, it reads, an information document that clearly indicates the risks and the benefits associated with the participation to the study was given to each patient. Patients received information about their clinical status during care, regardless of whether they participate in the study or not. And then it reads, patients who refused the treatment or had an exclusion criteria served as controls in the Marseille Center. Okay, so if I'm reading this right, someone who refused the treatment was still included on the trial as a control? Am I reading this right? To put it another way, someone refused the treatment but was still included in the study? It also reads, patients in other centers did not receive hydroxychloroquine and served as controls. So did those patients consent? Because it doesn't say. Might as well just pull anyone from anywhere who tests positive and say that they're a control, because as the study reads in a preprint, that's exactly what they're saying. Okay, fine, let's move on. So these patients on study are treated, and some get hydroxychloroquine, some get nothing. What happened? So if we look at the readout of the data, 36 out of 42 patients were enrolled. Of the 42, 26 received hydroxychloroquine and 16 were control. 6 hydroxychloroquine treated patients were lost to follow-up because they stopped treatment early. Why did they stop treatment early? 3 of them became critically ill and were transferred to ICU. Of the other 3, 1 died on day 3 but tested negative on day 2. 1 left the hospital on day 3 but tested negative on days 1 and 2. And the 6th patient stopped hydroxychloroquine on day 3 because of nausea but tested positive on days 1, 2, and 3. So I just want to bring up that 1 patient who died but tested negative the day before they died. What happens if somebody dies on day 7, but on this study, they tested negative on day 6, which then says it's a positive result on the study? It makes you think the 6th day is just not good enough. 4 of these patients, of the 6 who were excluded from this trial, who were on hydroxychloroquine, were taken out. 3 ICU, 1 dead. The data omitted these patients. That's 10% of the patients with not just a bad laboratory viral count, bad things happened to them after they started treatment. The study goes on to say that none of the control group patients were lost to follow-up. So this kind of thing does happen in every trial. Some patients do get lost during the span of a trial, even if it's only 6 days here. But usually the statistics would include a sensitivity analysis under different assumptions to see how that resulting data would be influenced by these patients. Or they would run a longitudinal model, that is a longer time period that could retain patients with missing data due to loss of follow-up. Neither of these were done here, but the reality is that you can't just drop patients who had a bad outcome, who happen to be the ones on treatment, because now you're really making it clear that your data is biased. Not just because the design wasn't robust in the first place, but because the investigator actively removed the points that they didn't like. I don't even like the thought of 3 people getting critically ill and 1 person dying, but there it is. 10% of the patients in the study removed just like that. Okay, so what were the outcomes of the trial? At 6 days after they were put on, 70% of the patients taking hydroxychloroquine were found to have no virus in their nasopharyngeal carriage, compared to 12.5% of patients in the control group. They concluded that there is a difference between the 2 groups due to the administration of hydroxychloroquine. The authors go on to bring out a subgroup of patients, 6 of them, within the hydroxychloroquine group that were also treated with additional azithromycin antibiotic, and 100% of those 6 patients had no viruses in their nasopharyngeal carriage after 6 days. Okay, why was the antibiotic azithromycin just brought out all of a sudden? Well, the authors cite in the paper that it would be to prevent bacterial superinfection. Nothing was described in the methods for saying that they were going to systematically include it in some patients, nor did they really give any other rationale for using it They kind of just threw it out there in the results and said 6 out of 6 who got this antibiotic on top of the treatment had no detectable virus in their nose after 6 days. They cited a paper that happened to be written by the principal investigator talking about how antibiotic could have broad, non-specific antiviral activity. That's great, except when they analyzed the data to see how control fares against hydroxychloroquine monotherapy against hydroxychloroquine with azithromycin, then they say that there's a difference. But if you take away the control group and you look at the significance between monotherapy versus doublet, there is no difference in adding azithromycin. But again, you're only comparing 6 patients versus 20. That's not to say that adding it wouldn't work, but the trial wasn't designed for that. So again, it doesn't tell us much. Also, azithromycin has a risk of QT prolongation, meaning that if you mix it with another drug that also prolongs QT interval like hydroxychloroquine, you can put someone at risk for having their heart flutter away just before it stops beating. And you can do this outside of the hospital because that's where a lot of people are giving this drug combination. You could treat it in a hospital if we weren't in pandemic. But remember, the people pushing for this drug combination are referring to patients who are outpatient, meaning that they're not in the hospital. So if you look at the supplementary table of data that the investigators put in their publication, it looks like they included 2 patients who were not receiving PCR testing in the control group. There were also 5 patients who didn't get the PCR testing on day 6 in the control group. I mean, there's only 16 patients in the entire group. If they reported a 12.5% number of patients who tested negative in the control, that means that 2 of them actually did test negative. That's 2 out of 16, 1 out of 8, 12.5%. These were patients 1 and 2 on the table. This means that the 5 patients who weren't tested at all in the control group were considered positive without having done a test. This also means in the treatment group, which had 20 patients, they had 70% negative, meaning that there's 14 who were negative on day 6. If you look at the table, there was 1 patient, patient number 29, who was not tested on day number 6. To count 14 patients, you need to include patient number 29, meaning they counted the patient who was not tested as negative in the treatment arm, but the patients who were not tested in the control arm were counted as positive. All of this should really tell you basically what every medically trained person has been saying these last few days at the end of March 2020. The trial doesn't tell us anything. Great, the medicine looked like it cleared some people's nose of the virus. It was subject to a lot of bias. It was poorly designed. And it looks like they intentionally changed the data to fit their own preferred outcomes, not only removing the people who had poor outcomes from the treatment group, but also skewing the data in their own testing calculations. This is the very definition of bias. I don't really care that they put out this trial. Like I said, I want this thing to work. And during this time, the French could have actually designed a robust trial that would be running right now and that would give us some more information on things that actually matter. Like, how does this impact the critically ill? What is the 28-day survival of patients who are on this therapy? Does adding azithromycin impact survival in the face of serious potential cardiac toxicity? The last one is really important because the evidence points to the fact that SARS-2 virus does in fact infect the heart and can damage the myocardium. I call this a study rather than a clinical trial because it really is just a series of cases that were strung together with a conclusion that hydroxychloroquine helps you test negative for SARS-2 virus. A better way to do this would be to coordinate a large multi-center study, maybe in New York City right now because it has so many cases, and distribute drug access through there, rather than let anecdotal single data points fly around here and there. We can capture something here, but it depends on how the state organizes this. Okay, so I want to end with some comments that I've seen floating around and answering them. The first one has to do with this. If medical people are saying that the evidence for it isn't good, then why are there reports of doctors in so many states writing prescriptions for themselves and their families? So to answer that goes back to our scientific rationale. There's good reasons why this medicine should work. We've already known of the general non-specific antiviral properties of hydroxychloroquine since the 60s. The French trial looks like the medicine clears out the virus from the nose. Combine these together, it looks like it could have an effect. We still don't know for sure. I've spent most of my career so far involving myself in multiple parts of actual large trials. Medicine is driven by the aspect of the unknown. We don't know if a medicine is going to work in a large group of people. And most importantly, we don't know if it's going to work for you. But when we do the trial, we can take a guess as to what the chance is that it's going to work for you based on where you are in the context of the disease. This is why anyone throwing around the word cure in medicine is not serious, because each and every single one of us who has ever touched a patient has seen a patient get an improvement in symptoms with treatment only to see them start to do worse, maybe right after things were starting to look good. Elon Musk wrote on March 25th, in response to a tweet that showed the table from this very French study. He said, "There should be a lot of data out by now," referring to the usage of hydroxychloroquine in COVID-19. The reason that there isn't is because on a clinical trial, you can't just pull data from anywhere. Then it wouldn't be a clinical trial. It would be a retrospective analysis, which in itself is subject to bias. Think about it. You can pull random data out of anywhere. There's plenty of confounding variables hiding inside. How about location, time? How about variations in treatment, variations in baseline per patient, variations in staging of disease? You can even choose where to pick the best data just to fit your hypothesis. Now, I know the tech and Silicon Valley mindset is to look as deep into the data as you can, but medical data is simply not the stuff that Google or Facebook or Amazon collects on us. Medical data is fragmented. There isn't a standardized system of reporting it. It tells an incomplete story. Unless you've determined from a start point how you want to treat patients and a proper inclusion and exclusion criteria on which patients you want to select, and keep with it for a longer period of time in an environment where you can control for specific variables and compare it to a current standard of care, you're not going to get good evidence for something by simply looking back at a pool of data. The only good tech analogy I have to this is that the retrospective data is a 64 kilobit per second MP3 file of a song, and you're re-encoding it to 320K in hopes that you're going to have a higher fidelity sound, but you end up with really only just a larger file size because you can't generate extra audio information that was lost when captured into a low quality source. Another comment reads, "There's absolutely no reason to demonize monitored azithromycin and hydroxychloroquine combination therapy. Treatment for torsade de pointe, QT prolongation, is IV administration of magnesium sulfate bolus, a very safe and easy protocol." This is obviously written by somebody who has never cared for patients in any kind of setting. You're actively putting patients at risk, knowing that their heart could potentially stop on this medicine. And if they're asymptomatic, the question is why would you put them at risk for that? Yes, sometimes there's no other option for treatment. We're going to give a medicine that we know is going to cause some kind of damage when there's no other choice. For example, for multi-drug resistant bacterial infection, sometimes we have to give really old and toxic antibiotics that are nephrotoxic. Otherwise, the person is going to die. We have to weigh the idea of nuking someone's kidneys in order to treat their infection because the bacteria simply won't respond to anything else. In the case of COVID-19, for a treatment that we've already shown that the trial is poorly designed and tells us nothing, when the hospitals are packed and overwhelmed, having an additional monitoring parameter for torsades, which is an abnormal heart rhythm caused by azithromycin and hydroxychloroquine put together, is putting the patient at risk of sudden death with a doublet that has no evidence for efficacy. Again, it could work, but we don't know that right now. When the hospital halls are overflowing with patients, someone getting torsades is probably going to be someone who's going to die from a medicine that you gave them, which again, has no evidence of efficacy. You're only doing harm here. The hydroxychloroquine azithromycin could work. I want it to work, but the evidence right now is not good. You're potentially putting people at risk of harm. And during this time, we could have been running trials that would be able to tell us a lot more about how it works. But hopefully in the coming weeks, we'll be able to get that.